Hello friends, welcome to the session on classification of common press working operations. In our last session, we have learned about the meaning of press working and its importance in sheet metal industry. In this session, we will learn about different common press working operations used to manufacture the various components from sheet metal. The press working operations are basically classified into three different types: shearing or cutting, forming or non-cutting, and finishing operations. What is shearing and cutting? Operations in which the shearing force is applied to cut, fracture, or separate the material. There are various common operations those are followed in this particular category. Next is the forming and non-cutting operation. The operations in which the metal to undergo desired shape changes without failure, excessive thinning, or cracking. Here also the many types of components falls in this particular category. And third is the finishing. The operations those are used to improve the surface characteristics. And there are certain miscellaneous operations as well where you may find that the combination of the shearing or cutting and forming and non-cutting operations. In some cases, you may find the combination as the cutting operations and the finishing operations, or the non-cutting operations and the finishing operations. Now let us see all these operations in detail. Now let us see the cutting press working operations in detail. Shearing operation. Shearing is the sheet metal cutting operation along a straight line between two cutting edges. Shearing is typically used to cut large sheets into smaller sections for subsequent press working operations. It is performed on a machine called power shear or shearing machine. The upper blade of the power shear is often inclined to reduce the required cutting force. In diagram represents the typical shearing operation. The system includes the shearing punch and the die. There are two views represented in the diagram. One is the left view, another is the front view. It is represented here that the shearing punch is provided with the specific angle or the inclination along the cutting edge. In this process, the force is applied to the shearing punch to cut the sheet metal into the pieces. This is a very common process used in industry to get these small pieces from the sheet metal of the required sizes. Second process is cutoff. Cutoff is a shearing operation in which the blanks are separated. This is called as a blank. The blanks are separated from sheet metal strip by cutting the opposite side of the parts in sequence. With each cut or new part is produced. The features of the cutoff operation that distinguish from the conventional shearing operations are: the cut edges are not necessarily straight. Here you can find that this cutting edge is not straight. Whereas in shearing, you may find that the cutting edge is straight because this edge is straight. The blanks can be nested. Nested means you may find that one blank here is represented in one direction and another blank is represented in another direction. So if you have these punch the cutting edge of the particular form, okay, you can get these nested blanks. Third operation is parting operation. Parting involves cutting a sheet metal strip by a punch with two cutting edges that matches the opposite side of the plank. Here you will find that the one cutting edge is matching to this cutting edge. Again, this cutting edge is matching to this cutting edge. This might be required because the part outline has an irregular shape that precludes the perfect nesting of the planks on the strip. Here you will find that there is a perfect nesting on the planks on the strip. The parting is less efficient than the cutoff in the sense that it results in some wasted material. If you compare this parting and cutoff, you may find that there is some wasted material present over here. Next cutting operation is notching and semi-notching. Notching involves the cutting out of portion of metal from the side of the stock strip. This is the stock strip. So from the side, so cutting get happen on the edges or side of the stock strip. Semi-notching removes a portion of metal from the interior part of the sheet. Here you will find that this is the example of the semi-notching. Okay, so this is now it forms a one edge of the strip. So half of the portion is in one section and half of the portion in another section. So you get the complete blank of any complicated form in a symmetric nature. Next cutting operation is blanking, a very common operation of cutting a flat shape from the sheet metal. The blanking involves cutting off the sheet metal along the closed outline in a single step or a separate piece from the surrounding stock. The piece that is cut out is the desired product. It is known as the blank. The hole and the metal strip left behind is discarded. It is also called as the scrap. The similar kind of the operation is piercing. It is also called as the punching. Piercing is similar to the blanking except that it produces a hole in the stock strip of in the required form and separated piece is a scrap. It's called as the slug. Remaining stock is our desired product. Blanking and piercing are the common operations required to produce the components from the sheet metal. For blanking and piercing, we require punch and the die. Those can be designed as per the required product. Next operation, cutting operation is perforating. Perforating involves the simultaneous punching of a pattern of holes in sheet metal. These are nothing but the multiple piercing operations. Here it is required one punch. Here you may find the number of punches of similar shape. Next operation is the slotting. Slotting is the term sometimes used for punching operation that cuts out an elongated or a rectangular hole. It is just similar to the punching. Only difference is that the cutouts are in the form of a rectangular form or the elongated. In last two slides, we have seen the different cutting operations. For getting the components from the place working operations, you can have the forming or non-cutting place working operations as well. First is bending. Bending in sheet metal work is defined as the staining of metal around the straight axis. In this operation, the metal in the form of the flat sheet or the strip is uniformly straight around a linear axis. During the bending operations, metal on the inside of the neutral plane is compressed while the metal of the outside of the neutral plane is stretched. In the diagram, you can see that in a bending operation, we require the punch and the die. This is the simple example of the V bending, where the punch is forced and the die is having a typical form or the shape. The particular cavity is of a required form as a V form as represented. The another example is shown, that is the edge bending, where you will find that there is a sheet stock strip and the punch, the blank holder, dissections and the punch, where the force is applied to the punch to get the desired bend along the edge of the stock strip. This is a simple bending operation. So many sheet metal components are required these operations. Second is drawing operation. Drawing is a sheet metal forming operation used to make a cup shaped or the box shaped parts, just shown over here. It is performed by placing a piece of a sheet metal over a die cavity and then pushing the metal into the opening of the die cavity with the punch. Here in the drawing operations, we required again a punch of the required form, then die cavity of the required shape, and the blank holder. Here, the force is applied to the punch on the blanks to get the desired form. During the process, the blank must be usually be held down or flat against the die by with the help of the blank holder. You may find the common parts made by the drawing include the beverage cans, sinks, or cooking pots, and the automobile body panels. There are many number of uh, components are produced by using um, this type of drawing process. So it may be no, it is called as the deep drawing process as well, where the depth of that particular the hollow section is more. Another operation is the ironing. In deep drawing process, the flange is compressed by squeezing actions of the blank perimeter, seeking a smaller circumference as it is drawn towards the die opening. Because of the compression, the sheet metal near the outer edge of the blank becomes thicker as it moves inward. If the thickness of this stock is greater than the clearance between the die and punch, it will be squeezed to the size of the clearance, and that process is known as the ironing process, where the thickness is get reduced throughout the section as the same. The ironing makes the cylindrical cup more uniform in wall thickness. Many times this can be combined with the drawing operation. Next process is coining and embossing. Coining is frequently used in sheet metal work to form the indentation and the raised section in the part, as shown in the particular example here. The indentation results in thinning of the sheet metal and the raised section results in the thickening of the part. Similar kind of the operation is required for many of the components. It's called as the embossing. It is a forming operation used to create the indentation in the sheet metal, such as the raised, lettering, and strengthening ribs. The operation may be similar to coining. However, embossing dies possesses the matching cavity contours. The punch contains positive contour and the die contains the negative contour, whereas in coining dies may be quite different cavities in the two die halves. So coining and embossing is again the forming operations used to make the many components. Third category of press working operation is finishing press working operations, in which you may see that there is trimming operation. The trimming operation consists of cutting the unwanted excess material from the periphery of the previously formed parts. So for example, this component is produced by the drawing operation. So in the drawing operation, this flange may get the uneven section. It is necessary to get the even section on the edges. So this unwanted material can be trimmed out. So the process is known as trimming operation. Second is shaving operation. The edges of the blanked parts are generally rough, uneven, and unsquare. Get the accurate dimensions of the part by removing this strip metal along the edges. The operation is known as the shaving operation, where you may find the large force requirement and the very minute clearance between the punch and the dissection, where the stock strip is shaved. Next is the fine blanking process. Is again the finishing process. The shearing operation used to blank sheet metal parts with closed tolerances and smooth straight edges in one stock. It is just similar to the blanking operation. The difference is that very close tolerances are maintained here in the process, where you will get the fine cutting in the pierced hole, or if you want the specific blank of a very precise size, so there we can use the fine blanking process. There are certain miscellaneous working operations. It means we can have the combination of different working operations. For example, slitting. The operation refers to the operation of making incomplete hole in the workpiece. So here you may find that this particular section, this section is cut along this edge, and another parallel to the other side there is a cutting. This is known as the slitting operation. Next is the lancing and lowering. This is the form of the lancing process. It is a combined combination of cutting and bending operation, or you can say the cutting and forming operation, where the component is cut from the three edges and bending is done at one edge. It is done in one step. A typical example of this is the mosquito coil stand. Lowering is another process. You may be noticed that our air conditioner or refrigerator, no, that requires the fin sections or air vents, no. So there, this kind of forming is done. So here, one edge is having the cutting and the three edges is having bending. So just opposite to the lancing process. This is known as the lowering process or lowering operation. The third one is the twisting of a sheet metal, where one side the particular sheet is clamped and another side it is again they hold it in another punch and the rotation is provided to get the perfect twist to the sheet metal. These are the miscellaneous place working operations. So till now we have seen cutting operations, non-cutting operations, and the combination of cutting and non-cutting operations, as well as we have seen the finishing operations as well that is performed to get the components from the place working operations. Now test your knowledge. Let us see first which placed working operations used to make this component. Just think for 5 to 10 seconds. Got it? Yes. The outer shape or these all edges, you find the outer shape is processed in blanking operation. Whereas this hole and this hexagonal hole is produced in punching or piercing operation. Very good. Number two, have you seen this component anywhere? So tell me that which operations are used to make this part. There are number of operations mixed, combined. Got it? Yeah. So this involves the blanking, piercing, lancing, and embossing operation. So this outer edge we get it from the blanking process. This you may find, is a punching or piercing. Then this is having the three side cutting and one side bending, so that's why it's lancing. And this is provided with the embossing operation as well at along this edge and this edge here. So this component is produced by using the combination of all these operations. In summary, we can see that the sheet metal operations done on a press may be grouped as cutting, forming, non-cutting, and finishing operations. Few components can be produced by using the combination of cutting and non-cutting operations as well. So in this session, we have learned about the different common press working operations. Those are used to manufacture the components from the sheet metal. So in our next session, we are going to learn about applications of pressed parts and components. Thank you.